Hello and welcome back to Zuluwa Consultants. In this video, we want to answer this question under the topic chemical kinetics. The question reads, a conversion reaction in a gas phase is a first order reaction with the rate constant of 6.73 times 10 to the power negative 4 and the unit is second negative 1. This is happening at 500 degrees Celsius. The first question says, if the initial concentration of the reactant is 0.25 m, what is the concentration after 8.8 minutes? So when it comes to this question, we need to take note in which order the reaction is taking place. So in this case, we have been given that the order is the first order. So you need to remember this equation. This is the equation that obeys the first order reaction. After you look at this equation, we have the concentration at a given time here. Then we have the rate constant, the time, and the initial concentration. So when you look at the question that we have the K value, which is the rate constant there. We have the initial concentration, we have the time. So they have asked us to find the concentration after 8.8 minutes. Now, when you look at the rate constant, the unit is in second. The time we have been given is in minutes. So the first thing you do is to convert these minutes into seconds so that the units are the same. So you need to look at the units of the rate constant, then it will guide you to see either you need to convert this time or not. So in this case, we need to convert the time. So let's start with the time and converting it. So we have been given 8.8 minutes. When you multiply this by 60 seconds, it gives us the time that we will be using. So 8.8 multiplied by 60, it gives us 528 seconds. So this is the time that we will use in our equation. Now that we have the time in seconds, we can go back to the equation there where we are saying the natural log of the concentration at a given time is equal to negative of the K value, which is 6.73 times 10 to the power negative 4. This is multiplying with the time, which is 528, then plus the natural log of 0.25. So we have the natural log of the concentration at a given time is equal to, we are multiplying 6.73 exponent negative 4, multiplying it with 528. It is giving us the value of negative 0.355 plus the natural log of 0.25 is giving us negative 1.386. So this is the natural log of 0.25. So we go to a natural log of 80 is equal to, so we have negative 0.355 plus negative 1.836. It is giving us the negative value of 1.741. At this point, for us to get the concentration of AT, we will use the exponential function of this value we have. So this is a rule on the exponential function that the natural log can simplify by introducing the exponential function. So we'll have at as the exponential function of the answer we got. It is giving us 0.175 m. So this is the concentration that will remain after 8.8 minutes. The second question reads, how long will it take in minutes for the concentration to decrease from 0.25 m to 0.15 m? Now, for us to find this question, we need to remember this equation for the first order reaction, and we have the natural log. The concentration at a given time is 0.15. Then the concentration at initial is 0.25. This is equal to negative of the rate constant, which is 6.73 times 10 to the power negative 4, and we have the time that we have been asked there. So what is the natural log of 0.15 divided by 0.25 gives us 0.6 is equal to negative 0.73 times 10 to the power negative 4 t. At this time, we can make t the subject of the formula by dividing both sides with negative 6.73 times 10 to the power negative 4, and this side negative 6.73 times 10 to the power negative 4. These two will simplify. We'll have t is equal to natural log of 0.6 divided by negative 6.73 times 10 to the power negative 4. Let us now do this on the calculator. We are saying the natural log of 0.6 divided by, open bracket, the negative 6.73 times 10 to the power negative 3. It is giving us 759.0 seconds. Now remember, this should be in minutes. That's what they have asked us. So 759 divided by 60 seconds, then we are changing it to minutes. So this answer divided by 60 seconds, it gives us 12.63, and when you round it off, it's same as 13 minutes. So these are the minutes that will be needed for the concentration to come from 0.25 to 0.15. The third question reads, how long will it take in minutes to convert 74% of the starting material? So when you have been given the percentage, you need to realize that when the reaction is starting, the percentage is 100%. Now, 74% of it has been used up. So how much is remaining? When you say 100, you remove 74, you are remaining with 26%. So that is the amount of the reactant that has remained. And that is the concentration at time t. So when you come to natural log, you will say at time t, 26% is remaining. Now this is out of the 100% that we started with when the reaction was starting. Then this is equal to negative of the rate constant, which is 0.73 times 10 to the power negative 4, and the time that we have been asked to calculate. At this time, let's divide 26 and 100. It is giving us 0.26. This is equal to negative 6.73 times 10 to the power negative 4 t. we can divide both sides by negative 6.73 times 10 to the power negative 4. Even this side, negative 6.73 times 10 to the power negative 4. So this will simplify. T is equal to the natural log of 0.26 divided by negative 6.73 times 10 to the power negative 4. So let's divide, let's see the answer there. The natural log of 0.26 divided by the negative of 6.73 exponent negative 4, we are getting the answer of about 2001.5 seconds. So remember, the question is asking us to put that in minutes, so we'll divide this by 60, and it is going to give us, when you divide by 60, it is giving us about 33.35 minutes. So this becomes the minutes that is needed for us to use up 74% of the starting material.